Okay, and welcome to the next video on integration, where we're going to look at how integration is useful for us in the A-level course to do a variety of things, and we're going to expand on the ideas on the previous video where we looked at finding general solutions to try and find particular solutions and to use integration to find areas under curves. Okay, so there are two main purposes of integration at this level. Firstly, if you know what dy dx is and a point on the curve, integration can help you find the particular solution. So essentially, if you know what the gradient function is, and gradient function is basically dy dx, if you know what that is, and you know of a point on the curve, a coordinate on the curve, you can find the original equation of the curve with that plus c as well. Okay? So in general terms, if dy dx equals f dash x, then y equation is the integral of that f dash x. Another thing that's a use of integration is to find the area between the curve, any curve, and the x-axis. So you can use integration between two limits, the limits normally being x values, such that you can find the area. Now remember what I said in the previous video, that this symbol is what we use as a sum. Now, in a more technical sense, what we do is we split any area up into small strips, and as the width of those strips gets smaller and smaller as they approach 0, then if we add up all these strips, or we sum all these strips between the first x value and the second x value, then we can get the area of that curve. Okay, and that is basically what this helps us to do. Okay, so the technique for finding a particular solution for the first use of integration, and the use of integration to find area, they have quite a clear and methodical process, and you need to follow that really well to get all the marks. So we've got this question here: y equals x squared minus 4x plus 5, and it's sketched below. Part A just asks you to find the integral of it, or to integrate it. Now if you remember in the previous video, when you've got the symbol here and dx there, that means you have to integrate. And remember what we do: we add 1 to the power, divide by a new power. This is to the power of 1, so you add 1 to the power, divide by a new power. And we put an x next to the number, and we have a plus c. We can rewrite this a bit further, because 4 over 2 is 2, 5x plus c. Okay, so that's the integral. That's part A. Hence find the shaded area. Now, remember what I said: if you integrate between two limits, so what we do is we set up the integral, and the top of the sum sign, we're going to put the second x value, i.e. the highest limit, which is 5, and at the bottom I'm going to put in 4, the starting limit. Okay, and that basically says to me I want to find the area of this curve between 4 and 5. Okay, so now what I need to do, I'm going to use my part A, and when I do this type of integration, and this is called definite integration, okay, so this is really important that you understand this. Definite integration helps us to find areas. Then what I do is I have to use these square brackets, okay, and outside the square brackets I'm going to put the number 5, which is the uppermost limit, and the number 4, the lowermost limit, and the top corner and the bottom corner. And what I'm now going to do is substitute in these values and find out what the area is. Okay, so if I substitute in 5, Now we're going to use round brackets for the substitution of these numbers. Okay, so 5 cubed is 125, to get 125 over 3. 5 squared is 25 times by 2 minus 50, plus 5 times 5, 25. 4 cubed is 64. 4 squared is 16 times by 2 minus 32. 5 times 4 is 20. Okay. And then, the most important aspect of this working is ensuring that you show all substitutions and ensuring that you get all the correct signs and values. These sorts of definite integration questions, especially we have to find areas, it's very easy for students to get this wrong just by doing careless errors. So I'm going to do the first bracket, 125 over 3 minus 50 plus 25, 50 over 3. The second bracket, 28 over 3. Now 50 minus 28 is 22, so you get a final answer of 22 over 3. That's the area. Now why does this work? Why do you substitute 5 and why do you substitute 4 in to get the final answer? Well, when you substitute 5 in, that will get you the area from 0 all the way up to 5. And when you substitute 4 in, that will get you the area from 0 all the way up to 4. Okay, underneath the curve. And obviously, if we know the area all the way up to 5 from 0, and we know the area all the way up to 4, then by subtracting the area up until 4 from the area up until 5, which is what we're doing here, we get the area that we need. Okay, the shaded area. And that is our final answer, 22 over 3. Now, in terms of units for this, there is graphical units squared, but normally you can leave it as 22 over 3. So let's just recap this first use of integration to find area. You have to establish the limits of the area that you're finding, the shaded region. So you put the lower limit at the bottom, the upper limit at the top. You then integrate using conventional rule of integration. You have to show these square brackets, upper limit, lower limit, and then you use curved brackets to show your substitution, being very careful that you're getting the correct values and signs in the correct places, and then working through very methodically to get your final answer. Okay, so that's a first usage of integration to help you find area. Now on the next page, what we're going to do is use integration to find a particular solution given some information. So we've got this situation, we've got a curve which has this gradient and it passes through the point 24. Find the equation of C. This is very typical in terms of the style of question you can get in A level, and students often struggle with this, and it is just an integration question, but they can't put into, a lot of students can't put into context. You have to understand f dash x is dy dx. Okay, we've seen that before. So dy dx, that's your gradient function. Okay, that's really important that you understand that. So you've got this curve, and somehow, well, you differentiate it and you get this equation. Now, if you differentiate a curve and you get a quadratic, that must have meant that we had a cubic situation. Now, obviously, you don't have to always think about the original curve, but it just helps in this situation. I know that if to differentiate to get a quadratic, I must have had a cubic before. Now, this curve C, which we don't really know what the exact equation looks like, differentiates to give you this, and apparently this curve has a point 24 on it. I'm just going to say it's there for the sake of argument. We now have to find the original equation of C. Now, you've got the dy dx. You then have to remember that by integrating f dash x with respect to x, you get your original y equation. Okay, so I'm now going to integrate my f dash x with respect to x, add 1 to the power, divide by the power, so you get 3x cubed over 3, which just gives you x squared. Okay, add 1 to the power, divide by a new power, so you get 4x squared over 2, which gets you 2x squared, and then the minus 3 integrates to minus 3x, and you have a plus c. So we know the equation of the curve looks like this, okay, just from the information given to us above. However, we don't know the c, and actually we can find that by using this coordinate. We know that 2, 4 is on the curve. So if 2, 4 is on the curve, that means I can substitute in 2 for x and 4 for y and rearrange. To get the value of c. So you get 8 plus 8, which is 16, minus 6, which is 10. 10 plus something that's giving me 4, c is equal to minus 6. And therefore, the final equation of the quadratic is as follows. And that is a particular solution using integration. This is a very powerful technique. Using integration can help us find the original equation of curves if you know what dy dx is and you know a coordinate on the original curve. Okay, and again, the way that you set things out is really important as well. Okay, now I'd highly recommend that you do some practice on finding areas and finding particular solutions. These are textbook pages outlined here, and they're well worth having a go at. See you in the video.